Today is section 19.2 out of Springboard, and it is negatives and zero powers. Yesterday we talked about, canceling out when we divided and multiplying, and now we're going to kind of combine that with some new things. I'm going to write my work on these sticky notes just because I did not photocopy them. Okay, so I want to talk to you about when an exponent is negative, and this just says when an exponent is negative, we're going to move it, and we're going to come back to that in a minute. Remember yesterday when we were doing this problem, x to the fifth divided by x. Basically what that means, and you should have this visual in your head, is that you have 5 x's on top and 1 x on the bottom, and when you cancel it out, you end up with x to the fourth, and they're all in the numerator spot. All right, and most of our problems yesterday were like that. Okay, so now I want to show you, and we did one problem, kind of touched on it really quickly about something that would look like this. And so same process, right? When you draw it out, you have 1 x on the top, and you have 5 on the bottom. All right, well, remember we were doing this 2 different ways. One, the people that need to draw it all out, and I really recommend drawing it all out if you are not catching on. Like the minute I say something, drawing it out just helps you understand it, and you'll remember in 6 months. The people that are doing the shortcut, that's great too, but chances are you might forget that. Okay, so if we had x divided by x to the fifth, you cancel your x's out, and then you end up with x to the fourth, and you have to put that on the bottom because your extra x's are on the bottom. Now, you've never seen a fraction written like this with nothing on top, so you have to put a 1 there. Okay? Now, the people yesterday that were doing the shortcut, they would have said, well, Miss Knight, what I did is I put x to the first. If you don't see an exponent there, it's a 1. So they went x to the first, and then they subtracted this exponent. And they would have gotten x to the negative fourth. So right now, what you should notice is, hey, wait a second. This 1 over x to the fourth is the same thing as x to the negative 4. Okay, those are the same thing. Now, technically, to be in simplest form, you should not have a negative exponent. So if the problem says simplify, your answer needs to be in simplest form, which is this guy right here. Sometimes the question will say, write your answer using negative exponents, and then you would have to write it like this. Okay, so it sort of depends on the way the question is worded, but if it just says simplify, then you don't want to have a negative exponent. All right, now this is kind of how I like to do these. Going back to my comment up here when I said when an exponent is negative, move it. I like to do that first. So what I do, sorry, I'm just going to take off some of these. What I like to do is I like to set up my fraction, and then I just move stuff around. I say, okay, x to the fourth, that's a positive exponent, so that's going to stay. X to the third, positive exponent, so it's going to stay. Y cubed, those are both positive exponents. Whoops. Oh, wait, that should have been an x. Let me rewrite that, sorry. Okay, so I have x to the fourth, it's positive, so it stays. X cubed, it's positive, so it stays. Y cubed, positive, so it stays. Y cubed, positive, so it stays. Y to the negative 2. If I have something that is raised to a negative power, I move it. So this is on top, so I move it to the bottom. And when I move it to the bottom, it changes from negative to positive. So once I move it, it changes its signs. Okay, this is already a positive, so it stays on the bottom. Now I have set this up, and now I'm just going to keep working here. And so now I do my picture. What cancels out? Well, some of you guys are going to be able to do that shortcut in your head. Some of you guys are going to be able to, but this is what you should be picturing. I don't necessarily think you're going to be drawing these out every single time, but in your head, this is what you should be picturing. When it comes to the x's, you should be picturing 4 x's on top, 3 x's on the bottom. When you cancel them out, you have 1 extra x, and where is it? It's on top. You have 3 y's, and you have 3 y's on the bottom. Not that you have to write this out, but this is what your mind should be saying to itself. Those all cancel out, so you don't even have to write y's. You have 2 z's on the bottom here, multiplied by 2 more z's, so you have z to the 4th. So right now when you're first starting off, I like for my students to write this out, and then eventually that's just what you're going to picture in your head. You're going to say, I have 4 x's on top, 3 x's on the bottom, cancel, cancel, cancel. Now I have an x to the first on top. Those are going to all cancel out. Oh, look, everything's on the bottom. And then I automatically have everything in positive mode. Okay? So let's go to this guy right here. Okay, same thing. A cubed, that's positive, so it stays on top. A to the negative 1, well, that's a negative exponent, so I have to move it. Once I move it, it turns positive. Sometimes just writing that one is helpful. It does look a little babyish, but this is just my work, so nobody's going to care. This b to the negative 2 exponent, I move it, so when I move it to the bottom, it goes positive, and this stays the same because it's positive. All right, now if I were to picture that in my head, I'm going to have 3 a's on top and another a. So now I have a to the 4th, and that's in my numerator. And my denominator, I have 2 b's, and then I have 3 more b's. So I have b to the 5th. Remember, you're going to start getting to the point where you're just picturing that and you're not drawing it out every time. Okay? Okay, here. So a to the 4th, that's a positive exponent, so it stays on top. A squared, that's a negative exponent, so I move it to the top. B squared, negative exponent, so I move it to the bottom. Remember, once I move it, it goes positive. B to the negative 1, I have to move it. I might put that just to make it easier. A to the negative 4, move it. I'm sorry, C to the negative 4. C squared. And now everything is positive. So my A's, I have A to the 6 because I'm picturing 4 A's and 2 A's. I put them together. B, 1 B here and 2 B's here. So if I had 1 on top and 2 B's on the bottom and I cancel it out, my extra B is on the bottom. And here I have C to the 4th and C squared all in the bottom, so that gets me C to the 6th. Now, let's say you're someone that's doing the shortcut. I just want to show you that the shortcut will still work. Okay, with the same problem, if you were doing it the shortcut way, which was just subtracting, right? And you said, okay, 4 minus negative 2. All right, we're just looking at the exponents here. 4 minus a negative 2 is 4 plus 2, which is a to the 6th. Here, b negative 2 minus negative 1, that's negative 2 plus 1, which is negative 1. Here, negative 4 minus 2 is negative 6. And then from there, you could switch stuff around. Well, that's positive, so it stays on top. This is negative, so it needs to move. This is negative, so it needs to move to the bottom. Okay, see how these are the same answer? So if you do it the top way, where you move all your negatives first, to me this is easier to picture, stretch it out, that's what you get. Or if you're really good with negatives and you do the subtraction method, you could get that and then later on convert it. Okay, it doesn't really matter which way, you'll get the same answer, but I would recommend just picking one and sticking with it. Okay. So I'll put this underneath here. So for here, we are going to leave and stay. All right, w to the 3rd power is positive, so I'm going to leave it. W squared, positive, so it's going to stay. X to the negative 2, I move it and it turns positive. X cubed stays because it's positive. Z to the 4th stays because it's positive. Z to the negative 2 moves because it's negative, so I move it on top. Now, I just picture in my head, I have 3 W's on top, 2 W's on the bottom. I cancel, and my 1 W, my extra W is on top. 2 X's and 3 X's, so I have X to the 5th. 4 Z's and 2 Z's, so I have 6. All right, And if you did it the other way, I'm going to go ahead and show you. If you did it the other way, but you're getting a little mixed up, what you're doing here is you're saying W, and this is all going to be in the numerator spot at first. 3 minus 2, so you're going to have W to the first power. And then you're putting your x's. X, you have a negative 2 minus 3, so that gets you x to the negative 5th. Z, 4 minus a negative 2. Z to the 6th. And now you're going to have to shuffle things around so that W stays on top because it has a positive exponent. This has a negative exponent, so it moves to the bottom, and that stays on top, positive exponent. So we got the same answer. That was what we got the last time we did this. So same answer. One of them we did the subtraction method, and one of them we moved stuff first, and then we just kind of picture it in our head. Okay, another kind of cool trick is that anything raised to the 0 power is 1. So 5 raised to the 0 power is 1. A raised to the 0 power is 1. B raised to the 0 power is 1. And even all of this. This whole thing is being multiplied, and then I raise it to the 0 power, so that answer is always 1. All right, they love to ask these kind of questions. If you have any kind of speed drills or competitions and you're trying to go fast, keep an eye out for that, because they love to bring that up, because the people that notice something is raised to the 0 power have to do hardly any work, and boom, they get their answer. All right, that's it for today. See you guys tomorrow.